We've been talking about while loops, and so now I'm going to go through some specific types of while loops. First, we have the count controlled loop. So there's some kind of a counter that goes up to a threshold or down to some threshold. The sentinel loop maybe gets input or something's happening, and we're looking for a certain specific value to stop. Every other value, keep going. And then there is a do while loop. We do not actually have a do while. Some languages do, and they have a block of code, and then the while statement is at the bottom. We cannot do that, but what we'll do is we'll put our while statement at the top, but make sure that the loop runs at least the first time. And then we'll have some kind of a test at the bottom that we really give to the top of the next loop, and it works just like a real do while. The 99 bottles song is a count controlled loop. Num bottles is the counter, starts at 99, counts down. When it gets to 0, the condition is false, and we drop out of the loop, song is over. For sentinel loops, we have a couple of examples. And first, I'm just going to show you the behavior, right? So we're not even looking at code, but here's the behavior. The first one, put in a bunch of non-negative numbers and end with a -1. So user puts in 1, keep going. User puts in 5, keep going. User puts in 100, keep going. User puts in 0, keep going. User puts in -1, we're done. The second one here, the user is supposed to put in words until they put in the word exit. So the user puts in show, keep going. The user puts in get, keep going. User puts in delete, keep going. User puts in exit, now we're done. So that would be controlled by a sentinel loop that's looking for that specific thing. If it doesn't get it, it keeps going. And here's the code for the first one. We get the user to input a number. If it is not a -1, and presumably it's not, it wouldn't be, if the user wants to run the program at all, you figure they're going to put in at least one number. So it runs the first time, and then we let them put in another one, and they keep doing that. And then when they put in a -1, comes back here and tests. -1 does not equal -1, and that's false, and we drop out. Now, this statement here, you entered a -1. In a real program, we're worried about the data, not the sentinel, but just so you know, so we can explain what's going on here. Yeah, you put in a -1, and that's what causes it to get past the loop. So like I said, a do while, block of code, while at the bottom. Python doesn't really have it, but we just have to make sure you get through the loop the first time, and then there's some kind of a test at the bottom that is, or that was carried up. The beginning of the next loop really does the test, and it works the same. Now, for this to work, you have to have a variable that is outside the loop, and set it to a value that makes the test true the first time through. You may not even use that value, but we just want to get through the loop the first time, if we're mimicking the do while business. So you set the variable to get through the test the first time, then the loop does its thing, and then the next time around we'll have another value that really tells if we want to go on or not, to test the condition. One thing to note, and this is true of regular while loops as well, there's got to be something, there has to be something that happens in the loop that changes the value of the variable eventually to stop the loop. Okay, here's an example, looking for Pikachu. Name, we just set it to unknown. And name does not equal Pikachu. Well, that's true the first time through. Unknown does not equal Pikachu. So it runs the first time. And then it says, I'm looking for Pikachu, and lets you do some input to say who you are. The second time around, then it's really testing your first input. So it decides, if you type in Pikachu, you're done. If you don't, it keeps going. Now, one thing I notice here is somebody has copy pasted this onto the slide. You notice this double quote here is not the straight, but it's got some shape to it. When you copy paste quotes, sometimes, especially Word documents, sometimes you get these smart quotes, and unfortunately Python may not know what those are, and you'll get totally weird errors. So watch out when you copy paste whole examples of stuff with quotes in them. Here's another example of a sentinel loop. We have a flag, a variable called keep going, and set it to 1 does not equal 0. That's true. So we're going to do the loop print. Obviously, in a real program that's actually doing something, there's going to be more than just print, we would guess. And then at the bottom of the loop, we get a new value for keep going. We're actually asking the user, do you want to keep going? And if the user puts in 0, then this fails, right? 0 does not equal 0, false, and it drops out. So this sentinel, the users got the opportunity to type in the sentinel when they're done looping. Here's another loop, and this one has a Boolean flag that tells us whether or not we want to keep going, whether or not there are more numbers. So we start saying, true, there are more numbers, more than none, because we haven't started yet. So very first time through, are more is equal to true, sure. And then we input a number. Notice this print statement, this is just instructions. This could go anywhere. The first real input interaction with the user is here, get a number. If it's less than 0, that's the sentinel. -1, well, we're not. Any negative number would stop it because of this test here, and we'll say are more is false. There are no more numbers. If a user types in -1, then we want to quit. And so when that Boolean variable are more is set to a value of false, then this while fails, and we jump to the next thing, and we're out of the loop. And here is that loop with some actual work tacked onto it. So we still have the are more and the prompt to type in numbers until we hit -1. In the body of the loop, if next num is less than 0, okay, we're done. Otherwise, we're going to do this work. And this is sum equals sum plus next num. So you'll notice we've got sum equals 0 at the beginning. We start off with an accumulator. That's what this is called, an accumulator with a value of 0. And then down here, when we get a number that's not -1, we add it into sum and put that back into sum. So we're adding numbers into sum. We are summing up numbers. This is called an accumulator. And this program will add them up, as many as the user types, until the user types -1. And there I use the word until again. It will add them up while the user is not typing -1. While there are more numbers, keep going. Okay, and that is the end of my examples.